Hey there, and welcome. When most of us hear the word chemistry, we probably think of bubbling beakers and lab coats, right? But it's so much more than that. It's actually a huge universe of different fields, each one looking at a totally unique piece of our world. I'm talking from the tiny cells inside us all the way out to the most distant stars. So today, we're going to take a tour of these incredible worlds.
So let's start with a bit of a riddle. What do cancer treatments, the plastic pipes under your sink, and distant stars all have in common? I mean, they sound completely unrelated, right? Well, the surprising answer is chemistry. And not just general chemistry, but the specific, specialized branches that tie all these different parts of our universe together.
All right, so here's our game plan for this tour. We're going to dive into 6 amazing fields of chemistry. We'll start super small and then work our way all the way out to the cosmos. Let's get started.
Okay, first stop on our tour, we're going right into the very heart of matter itself, the atomic nucleus. Welcome to the world of nuclear chemistry.
So, what exactly is nuclear chemistry? Well, it's all about studying the incredibly powerful reactions that happen deep inside an atom's core. Just think about that for a second. We're talking about unlocking the massive amount of energy that's stored inside something way too small for us to even see. A really key process here is radioactivity. That's when the nucleus itself actually changes, and in doing so, it releases that huge amount of energy.
It's honestly incredible how this tiny little core can have such a gigantic impact on our world. I mean, the very same force that powers the sun, that's what we've learned to harness in nuclear power plants. And at the same time, that radiation it produces, well, it can be very carefully controlled and used in radiotherapy, which is one of our most powerful tools for fighting cancer. So when you boil it down, understanding the atom's core literally helps us generate power and save lives.
All right, for our next stop, let's zoom out a bit. We're going from a single atom to the amazing, complex world of life itself. Welcome to biochemistry. Biochemistry is, at its heart, the chemistry of, well, us. It's the chemistry of you, me, your dog, that plant on your windowsill, every living thing. It's all about exploring the countless chemical reactions that are going on inside ourselves every single second. And you've probably heard of this whole complex system of reactions before, just by another name, metabolism.
So what does biochemistry focus on? The big players, the key molecules that make life happen. You've got proteins, which are like the body's construction workers, building everything from muscle to hair. Then you've got carbohydrates, things like glucose, which are our main source of fuel. And of course, you can't forget the nucleic acids, DNA and RNA. They're the literal blueprint for every living thing. It's this field that helps us understand that beautiful, complex molecular dance that's happening inside of us right now, keeping us alive.
Okay, so we've looked at the natural molecules of life. Now our tour is going to shift to the giant molecules that we create to build our world. Let's dive into polymer chemistry.
The main idea behind polymer chemistry is actually pretty simple. Just imagine you have a single small piece, say a paperclip. Now imagine linking thousands and thousands of those paperclips together into a really long chain. Guess what? That chain is a polymer. So this whole field is the science of designing, creating, and figuring out these huge molecules that have totally shaped the modern world. And you see these polymers everywhere every single day, probably without even realizing it. Think about the pipes under your kitchen sink. You know, the white or gray plastic ones? That's almost certainly PVC, which stands for polyvinyl chloride. That tough, lightweight pipe is a perfect, everyday example of how we use these long-chain molecules to literally build the world around us. All right, let's keep our journey moving. Our next stop is a field that truly impacts all of our lives and our health. We're talking about medicinal chemistry. To put it simply, medicinal chemistry is where medicine comes from. It's the science that's all about designing, creating, and then perfecting the drugs that help us fight off diseases and just live healthier lives. So, you might be wondering, how does a new medicine even get made? Well, the journey usually starts with discovering a new compound that looks promising. Then chemists have to synthesize it, which is just a fancy way of saying they figure out how to make it in a lab. But maybe the most important step of all is the testing. Scientists spend so much time studying a drug's effects, the good and the bad, to make absolutely sure it's not just effective, but that it's also safe for people to use.
Okay, time to zoom out again. We're going from the lab all the way out to look at the chemistry of our entire planet. Our next destination is geochemistry.
Geochemistry is all about exploring the chemical recipe of our world. We're talking everything from the minerals buried deep in the Earth's crust all the way up to the very air we're breathing right now. It really helps us get a handle on the fundamental processes that shape our planet and make life here possible.
One of the most important jobs for geochemistry today is monitoring our environment. A great example is air quality. You know, healthy air has a pretty specific chemical makeup. But when pollutants, like smog, start to build up, that chemical balance gets thrown off. Geochemists use tools like the Air Quality Index, you might see it as AQI on the weather report, to measure these changes and give us a heads up when the air isn't safe to breathe.
And now for our final stop. We're leaving our planet behind entirely and heading out into the cosmos. It's time to look at chemistry on the biggest scale imaginable: astrochemistry.
So, astrochemistry? It's literally the study of chemical reactions happening out in deep space. These scientists are looking at molecules and ions on faraway planets, inside stars, and even in those huge cold clouds that drift between the stars. And yeah, you heard that right. Chemistry happens even in the almost empty vacuum of space. It's what creates the basic building blocks of the entire universe. So you might be thinking, okay, that's cool, but why does that matter to me here on Earth? Well, for one, astrochemists study how cosmic radiation is formed, and that can affect our satellites and even life itself. But even more directly, they help us understand how really crucial things, like the ozone layer protecting us from the sun's harsh rays, are actually formed and kept stable. It's a direct link between the chemistry of the cosmos and the health of our own planet.
And just like that, our tour is over. Let's do a quick recap. We started in the atom's core with nuclear chemistry. Then, we explored the reactions of life with polychemistry. We saw how we build our world with polymer chemistry and create medicines with medicinal chemistry. We learned how we watch over our planet with geochemistry. And finally, we looked to the stars with astrochemistry.
So what's the big takeaway here? It's that chemistry isn't just one single subject. It's this amazing web of connected sciences that explains our world on every single level, from the code in our own DNA all the way out to the makeup of faraway galaxies. And that really just leaves us with one big question. What incredible things will these fields of chemistry help us discover next? Thanks so much for coming along on the tour.